Hi, this is going to be a video about a specific feature of the ml5.js library, which is called ObjectDetector. And the clue is kind of in the name there. It's a feature of the library that can use a pre-trained model that knows how to detect specific objects in images and can tell you what it thinks those objects in the image are, as well as how confident it is that it knows what it's seeing. And it can do that in any kind of image, right? So a static image, just like a photograph, or a pre-recorded video, or the feed of your webcam. And indeed, this is it working right now, right? So you can see both that it is identifying that I am a person. It's very flattering. You can see that there's this bounding box around my personness. If I move away, the bounding box gets smaller. If I move towards the camera, it gets bigger, so it's always around me. And then you can see that there's a label there being printed on top of me that says person, because it thinks that I am a person, and a confidence value of how confident it is that I am a person, that this image, this part of the image is a person, which is at around sort of a little bit over 70%. So this is what ObjectDetector is for. It's for detecting specific classes of objects, okay? Now, we would like to use this in a project, right? And to do that, we're going to need to read the documentation. So what I want to get to in this video is going from knowing that this is a cool thing that we might want to be able to do to actually being able to understand how the underlying code works in terms of ml5.js and getting it working eventually on our own system. And the way that we're going to do that is we're going to read the documentation on the ml5 website. So I'm going to go to ml5js.org, which is the homepage of the library. And as always, I'm going to say no justice, no peace. Indeed, indeed. And I'm going to go to the reference. So this is generally speaking where we're always going to end up wanting to go now that we're using this library, is the reference part of the website. And the reference contains a lot of stuff, but importantly, if we scroll down in this left-hand pane, which has got the kind of table of contents, we're looking at image features, the parts of the library that can process images, and right at the bottom of the list is the object detector feature, which is what I want to use. There's actually a very similar feature of the library called image classifier, which I might look at in another video actually. But I want to look at the object detector one. It's a little bit arbitrary, but this is the one that I'm going to take a look at, right? And so the key thing that we need to do with any library is understand how to read its documentation so that we can work with whatever feature it is that we're wanting to use, right? So let's look at what we are provided with in the ml5 documentation for a feature. Obviously, we find out what it's called, which is Object Detector. We immediately see an image of it working. So this is that feature detecting a cat at 65% confidence, this gorgeous little tuxedo cat. And that immediately tells you, roughly speaking, what it does, right? It can draw a box, not a literal box, but it can determine the location in a larger image of an object. It can tell you what the object is and how sure it is that it is that specific kind of thing. So it's found the cat, where the cat is in the larger image, and it's 65% sure that what it is seeing is a cat. Then we have the description. This is very pithy. Real-time object detection system using either YOLO, which stands for you only look once, not you only live once, or Cocoa SSD models. So even though this is really short, this is telling us quite a lot of information. It's always worth reading these things and thinking about the implications. Importantly, we see real-time object detection. So although the example here is just of a static image, this is telling us that it can detect objects fast enough that we can actually process real-time input, which is cool. So it's not a thing where it takes half an hour to process an image, in which case it couldn't be real-time. It's fast. The other thing that it tells us is that it can use either the YOLO or Cocoa SSD models, and that is telling us that there are different kinds of models for object recognition. It's not just one model to rule them all, and this idea of different models tells us that there may be differences in the behavior of those models, right? That maybe one model is better at some things and not others, for example. Maybe the YOLO model is better at recognizing cats or something, or the Cocoa SSD model recognizes scissors, but the YOLO model does not, right? So it's not important right now to know those details. It's important to realize that the idea of using a different model in the context of machine learning is going to change what happens when we actually use it. So we do at some point want to care about these models depending on what we're trying to accomplish. For now, though, important just to kind of note this and keep moving. The quick start section here is the most basic conceivable code that you could write in JavaScript to get this thing actually working. This depends a little bit on your familiarity with plain JavaScript programming for the browser, because it's making some assumptions about things that we might know. The big takeaway, I think, right now is just like it's a really tiny amount of code to make object detection work in a program. Like, it's pretty surprising, I think, that you can do it with this little code, and that's the magic of ML5, really, in a nutshell. You can see that we're doing this thing here, which you may not be familiar with, or if you are, good for you, where we're actually getting a video input from a web page. That's what this little thing is doing here. It's getting a video element from a web page. So that's specific. This is the one part of this that's kind of specific to plain HTML, as this line here, to get the video input. Then you can see that we need to create the object detector object. This is typical of most libraries, right? Is that we need an object that represents the library or the feature of the library that we're using. So we can see that there's a special method here, ml5.objectDetector, that we use to create them. We can tell it which model we're using. We can see, because we remember that Cocoa SSD was one of the models we could use. There's a weird empty object here. We don't know what that means. And we can probably intuit that it's going to call this function called modelLoaded. If you were being a gambling person, it's probably going to call that when the model has loaded. One thing that this tells us, actually, and this is another important thing about these machine learning features, is that like many things in a program, it does actually take time to load the machine learning model. It's a complicated set of, it's a complicated algorithm / data that is being used, and so it doesn't load instantly. So we need to explicitly say, call this function when it's loaded. We can see that this function isn't really doing anything special. It's just notifying us that the model has loaded in the console when that happens. And the final thing that it is doing is it's calling on that object detector that we just created, that we created here. It's calling a method called detect, and this is kind of the business end of the feature where we are asking it to actually detect objects in an image. In this case, it's saying detect objects in this video feed. That's the first parameter. And here is an arrow function. If you're still not sure about arrow functions, I apologize on behalf of ML5. They're very common. What this is saying is that when it has finished detection on this video, it will call a function with these two parameters, an error and the results, if there are results of detection. It will call this function, and all that function does is it just prints out the results in the console. Okay, so there's a lot going on there. But this is a tiny amount of code for something that will literally watch a video and tell you as the video plays what objects it sees in the video. So pretty miraculous. Depending on what framework we're using, this might be even a good place for us to start if we're wanting to write our code in plain JavaScript, or it may just be an indicator for us of how to see what the basic pieces of this feature actually are. Okay. So we've identified kind of a structure here, right? You need some kind of input, in this case video. You need to create an object detector object and tell it which model to use. You may want to do something at the moment that the model has loaded. If you want a loading screen, for example, this would be a way to do that. And then you call this detect method, and that will perform a detection step and give you these results, these magical results that you will then presumably want to do something with. So this really gives us the basic framework. Even if we're not going to use plain JavaScript, it gives us the conceptual framework of how we might use this library. Okay. The real details of the stuff that we saw in the quick start are here in the usage section. So the usage section is literally telling us what the specific methods are that we can use when we're using this feature. And you can see that this is reflective of what we saw in the example, right? So we create an object detector object. They're calling it ObjectDetector with this ml5.ObjectDetector method. We provide it with a model name. They were using Cocoa SSD. We might remember that we could also use this one called YOLO. There's an options option, so that's what that empty curly brackets represented up here. Remember, we saw these empty curly brackets when it was using this ml5 object detector method. So this is an empty set of options, i.e. don't set any options, is what they're doing there. And then the final thing is this callback that will be called when the model has loaded. And you get like full-on explanations of each of those parameters here. That's the beauty of documentation if you really want to learn what's possible here. So for example, we see here that we can write Cocoa SSD or YOLO in lowercase to set the model. And we learn, for example, what the actual specific options are that are available. Interesting here that for YOLO, the options are filter boxes threshold, IOU threshold, class probability threshold, none of which makes much sense to us and are not explained here, which is not super helpful. And also that it doesn't tell us what the options might be for Cocoa SSD. So you can see that documentation is never perfect, right? There's always going to be something that's kind of missing from our understanding. And that's worth kind of dealing with. And then there's this optional callback, as we discussed. That's the function that's going to call when the model has been loaded. So now we have a deeper understanding of what this initialization method is going to do for us. And then carrying on, the other big thing that we saw was the detect method, right? That you say object detector, the variable with the object detector in it, dot detect, and you need to tell it what is the input. So what is it detecting on, an image or a video or a webcam feed, and then odd really that this is optional, but this is the function that you would call when it has made a prediction of what's inside the, that's inside the, that's in the image. Once it's made a prediction, it will call the special function, and that function is the thing that's then responsible for kind of processing and responding to the detection, okay? And again, we can read these details down here. Really the big thing that we want to pay serious attention to as people who want to use this is this question of the output, right? Like, what does this detection step output? And we see here that it returns an array of objects containing class names, bounding boxes, and probabilities. That's quite vague. That doesn't really tell us what that data is going to look like, but it gives us this idea that it's going to be an array because it might detect more than one thing at the same time. So it's going to be an array of things that it thinks that it found in the image. And the things in that array are going to be objects, as in JavaScript objects, with properties in it that describe what it thinks it saw for each object. And we can see that the properties are going to be things like what is the name of the thing that it saw, what is its bounding box, and what are the probabilities, the confidence. But it doesn't really tell us what that format is. So that's kind of a shame, but we will therefore have to figure out a way to respond to that. So we're still reading documentation. It's a good idea to just go through this like this. And indeed, that's most of what I'm going to end up doing in this video, to be honest. So the really strong part of ML5, I think, is that it provides really solid examples. And it provides examples such that it's really plausible to kind of work up from their examples into your own projects, because they kind of tend to do the key things that you want to be able to do, right? So let's actually look at one of these examples. They've got examples in ml5.js. This would be, these are on GitHub, so you can like get the actual underlying code. But really, I think a really good way to look at their examples is in the P5 web editor. So that's where I want to start. I'm going to start with the Cocoa SSD single image, just because it's a little bit more static. So I'm going to open this example up. Cocoa SSD single image. I'm going to head over to the web editor. And the great thing is here, if I run this now as well, so it's doing YOLO image detection on a single image, which is not actually true, right? So again, there are flaws, right? We can see that this is actually using Cocoa SSD. So it's actually not the case that it's using YOLO image detection at all. And we can see the result over here, right? So here's the program running. Here it has recognized the cat at 91%. I'm not really sure why now it's 91%. And In their example, it was only 65. That's a curious, curious distinction. It doesn't look any more or less like a cat right now to me than it did before, but who knows how these machines are thinking. So the key thing that we see here is that we've got the whole program that's doing this. And again, that means that we can kind of scan through this example and get a sense of how is it setting up a whole thing to do this. So we can see that it's got an object detector. That's good, that's important, right? That's the object that we're going to actually use to do the detection. It's got an image that it's going to perform detection on. We see that being used here in the preloader, where it's loading the specific image that it's going to do detection on. It's got an objects array. If we were guessing what that was, and we'll see as we go through the program, that's probably where the results of the detection are going to be placed, right? Because we know that the results will be inside in an array. And it's got this status variable that I would guess is about telling us whether or not the model has been loaded or not, although we will have to wait and see. Okay, so the preloader loads the image. This is just us reading through this and understanding how this program works. So we get an image. In setup, which is what is going to happen at the start of our program, we can see that it does its creation of the object detector, so ml5.objectDetector, tells it that the model is Coco SSD. We can see that it's not providing an object here with the extra options, or even an empty object. So apparently, that's optional, so that's good to know. And it's going to call this model ready function once the object detector has been created and is ready to do detection. And so importantly, we're not asking the program to do object detection until that model has actually been loaded. And that's why in here, this is kind of almost like a second setup, right? Like this is when the program's actually ready to do its machine learning stuff, is when model ready gets called. So it prints out, it says that it's ready. That's what we see down here at the bottom. Let me move this up a little bit. It sets status to true. That's, as now we can probably tell, we can see that that means that the model is ready, that detection can now begin. It says that it's going to do detection, which is why we see detecting down here. And then it calls that all-important detect method on the object detector, which tells it to go away and look at the image and come back with what objects it thinks are in there. So we say ObjectDetector.detect. We give it the image to detect, to perform detection on, and again, a function to call when that has happened, because it doesn't happen instantaneously. So there's going to be a delay between when we ask for it to detect something and when it actually finishes detecting. So we've got this whole idea of events, right? There's the model loads, we wait, and then it calls the model ready function. Then we say detect, and we wait, and then it calls the got result function. And in the meantime, our program needs to kind of know what to do while it's waiting, right? It should maybe display like detecting or loading the model or something. This one doesn't do that quite so much. So when there's a result, it calls this got result function. Importantly, just as in the documentation, just like we saw, the first parameter here is an error parameter. So that's if detection is broken somehow and something goes horribly wrong. And the second parameter is a results parameter. So that's where we will find that array of objects that were detected should it be successful. And so the way that they're structuring this in here, which is important, is they first have an if statement that is checking whether or not there was an error. If there was an error, then everything's ruined, basically. And it prints out to the console the error message, which will be inside the error. I would argue that they should really do console.error here to like make it a proper error that breaks the program. But they're not doing it that way. That's fine. Then it's printing out the results into the console. That's why we see this thing here, and we'll take a quick look at that in a moment. And then it's assigning the results into this object array that we had at the top of the program, so that we then know for the rest of the program, whenever there's been detection, the results of that detection are going to be inside this objects array. And that's, so that's nice that it's available to the rest of the program. That's important, right? So let's look inside this object now, right? So here in the console, we did this console.log of what the results were. So what did they look like? This is where we can actually start to learn a little bit more about the format of the data that's being provided. And so let me shift this up a little bit more. So the thing that came out is, well, it's an array. It's actually an array. It's printing out in a slightly odd way here for reasons I don't want to get into. But it's an array, and the first element in that array, indeed the only one, at position 0, is an object, and it's got these properties. It's got label, which is cat. We can see that that's being printed out over here. So the name of the thing that it thinks it found is called label. That's the property that we would use to find out what it's called. We've got this thing called confidence. That's how confident it is that it is a cat. You can see it's 0.913, and that corresponds to the number that we've got here. So it's a number between 0 and 1, where 1 is total confidence. We've also got an X and a Y. Those are the coordinates of the box that we could draw around that object. It's the coordinates of the top left corner that's worth knowing, right? So the top left corner is at these pixel locations, and the width and height of the box that you could draw around it are these dimensions. So it gives us an X, a Y, and a width and a height for a rectangle that we can draw around the object that it has recognized. So that's neat as well if you want to kind of know where in the image this thing is. In this instance, they've drawn a green box around it, right? And then finally, we've got this normalized property, which it's worth just kind of quickly peeking at. So it's the same thing, X, Y, width, height. It's another description of the bounding box. Normalized means that it's converted the kind of canvas pixel locations to numbers between 0 and 1. So X is 0.36, for example. That means that it's 36% along the canvas from the left. So it's just another way of representing the bounding box. So the good thing here by looking at this example is we've now actually seen what the data looks like, and that gives us a lot more confidence in how we're going to work with it moving forwards. So the rest of the program is not really doing very much. It's the draw loop, right, is making sure that the status has been set to true, which means that the detection has completed, and then it's displaying the image just as you might expect. And then it's going through all of the objects in the objects array, which remember is the results. In this instance, we know that there's just one object in that array which represents the cat, and it's drawing the rectangle around the X, Y, width, and height coordinates, and it's printing out some text that has the label property and the confidence property, so that you see this box around the cat and the word cat and the confidence. So it's accessing this data that we were just reading down here and displaying it in the most obvious possible way on the canvas. Okay, so that told us a lot, right? It gave us, again, it showed us a framework for how we can work with this in terms of loading the image, creating the object detector, having a model ready function that changes a status and starts detecting, a got result function that is there to grab the results and store them in our object, and then it's got some basic code just for displaying the results on the canvas. So it tells us a huge amount, and we can really go from this basic model into writing our own programs already, right? You could cut and paste this into your own project and make a project that does this kind of image detection. So that's great. I want to just quickly also look at the video-based one, just because we have it here. So I'm going to click through to their Cocoa SSD video. Again, I'm going to run it. That's going to fire up my webcam. Hopefully it works. Let's see. So real-time object detection using Cocoa SSD and p5.js. Oh, and it's got a bit of an error going on there. That's concerning. Let me try this again. Oh, there we go. Now it's happy. I'm not really sure what happened there. So you can see it's frozen right now, by the way, and that's because the model was loading and kind of like everything was getting held up. But now you can see that it's working. You can see that it's just like we saw in the example at the beginning. It's recognizing me and my bounding box, and unfortunately the door there is white, but you can see it says person in the top left corner. And indeed, if I hold up something else, like some scissors, you can see it's recognizing these scissors. Good job. Good job, Cocoa SSD. So it's the same idea, exactly the same idea as the previous example. It's just that now it's using the webcam. So let's go and quickly look at what the difference is. So it's unfortunate that they're using some different names here, but that's okay. So we've got a detector variable. That's the thing that's going to contain the object detector in it, just like it was called object detector last time. We've got detections. That was called objects last time. This time they've called it detections. That's the array of things that it found. And then really the key difference here is there's this bit here in setup. So in P5, if you want to access the webcam, this is what you do. So you have a video variable and you assign create capture with video in all caps. That will request access to the webcam. And when it gets it, it will put the reference to the webcam inside the video variable. And then here, they're resizing the video element that came back, and they're hiding it. And the reason for that is that when you do this create capture thing, it actually creates a new element on the web page itself. It's not a kind of JavaScript thing. It's something that's actually on the web page. And we don't want it to display on the web page. We want to do everything inside of our P5 canvas. So that's why they're hiding it here. Then you can see it's doing exactly the same thing to create the object detector. It's the same every single time. Model ready, you can see again, does this thing where it says detect. It gives it the thing to detect on. This time that's the video thing that we created, and it's going to call got detections when it's successfully detected. You can see how I had to skip, like I found model ready referenced here, but I had to skip over a function to find the model ready function. That's okay. And then the got detections function is the same as last time with one important difference, right? So it gives an error and a results. It says if there's an error, print out that error. This time they are using console.error, which is a good thing. Does the same thing, copies the results into our array so that we can use it later on. But importantly, because this is a webcam and we want to keep detecting objects every frame ideally, so that you can see that it's continually detecting me. It's not just detecting me once and stopping. That means that when it has received some detections and stored them away, it calls the detection function again. And that's what keeps it happening over and over and over again, right? So got detections, calls detect again, which calls got detections. So then when it has the detections, it comes back and then calls it again, and you go on forever, which is what we want in this case. And then the draw function is the same thing, right? It displays the image as you can see. And then for everything inside the detections thing, which in this case now there's two, because there's scissors in the person. Scissors are flickering in and out of existence because that's life. Now I really want them to be. There we go. It's going through all of the things in that detections array, which are the things that were found, and it's drawing a box and a label around each thing. Sorry, scissors, you don't exist as much as I do. Okay, so the big differences there are create capture to make our video, because that's what we want to do detection on. And when you get detections, you immediately ask for detections again so that it creates this continuous cycle of object detection on the video. And hey presto, we've got like a live version of object detection, which is very exciting. And again, this gives us a complete model for how we could do webcam-based detection. So that's really excellent. At this point, we're kind of ready to just really do stuff, but I just want to just carry on and just touch on the rest of the things that are listed here. So there's no demo. That's okay. There is a tutorial, so if you want to watch Dan Schiffman be enthusiastic about object detection, you absolutely should, because he is the greatest. I would suggest. The really useful thing, like you don't have to immerse yourself in this, but I've talked in another video about the importance of ethics and data. One of the things that ML5 is trying to do is provide you with information about where the data for these models is coming from, so that you can find out more and you can make your decisions about ethical use and these sorts of things. So it has these overviews of the models. I'm not going to go through this right now. But it is a biography, for example, of the Coco SSD model. It tells you that it detects objects defined in the Coco dataset. That's really important because it might feel like the object detector can detect literally everything, but you could see that it can't, right? It didn't detect anything behind me on the wall. It didn't detect the door. It only detected me and the scissors. So those are two things that it knows about, and it doesn't know about other stuff. So the big thing I think that I want us to just pick up on here is realizing, especially with these identification models, they can't recognize everything. And so if you want to know what it can recognize, how would you know that? And the answer is that it's a slightly complicated process to find out. So if we want to use Coco SSD, which I do, to find out what the objects are, it turns out, I had to figure this out as well, you go to the GitHub repository, because really if you want technical information about what this is, that's the place to go. So I click through to the actual repository. We're now talking about TensorFlow and a specific model, which is Cocoa SSD. And we go down here and they've got some technical description of how it works. And one of the key things is it says the model is capable of detecting 80 classes of objects, and it's a link. Okay? So if we click on that link, we end up in a file in the repository. It's getting pretty, we're feeling like pretty serious hackers now. It's a file called classes.ts, and here we finally find, in amongst some potentially confusing structures in JavaScript that let's not worry about, we find a list of things: person, bicycle, car, motorcycle, airplane, bus, etc. Somewhere in here will be scissors. I guess I can do a quick find on it. There they are. Scissors, teddy bear, hairdryer. It's kind of a pretty weirdly arbitrary list of things. I guess that they figured out some kind of list of particularly common things. Sure. But these are the only things. So I can find a toilet. These are the if you need one. These are the only things that Cocoa SSD can see in a very literal sense. So if you hold up something and it's not in this list, it's not gonna see it at all. So that's important depending on what you want to do with it, right? So this list of classes is potentially an important resource that you now know about. Okay. And then continuing on, they have more stuff about the biography, how was it created, YOLO, they have the same thing. And then there's just like the cool people who made this thing who you should be thanking in your sort of prayers when you're kneeling by your bedside. And some stuff maybe that's not been done here. It says etc. And you can even look at the actual code for the object detector if you want to. I'm not going to do that right now. So that's really, really great, right? So we've looked at this whole thing. We've gone through. We understand what is going on. And we've seen these frameworks, thanks to the examples in particular, supported by the documentation that we can read and see what the different options are. And we've got this whole kind of little framework that we can then use to do our own object detection. And so what I want to do, just in finishing, is I'm going to go over to my car263 repository. I kind of wish that I didn't have these things open. Just ignore that. And I'm going to get a template P5 project. I'm going to copy that. And then I'm going to go into my AI folder. I'm going to paste it in there. And I'm just going to call it Object Detector, because that's what we're working on right now. And I'm going to throw this into Atom. And I'm just going to really quickly, what I want to do is just show you a template that we can use. So this is a more sophisticated, not more sophisticated, just a little bit more polished maybe than what we were seeing earlier in the examples. But I'm providing this just as like a more detailed framework that we can look at. Ultimately, it's the same thing that those other frameworks were using. It's just got some extra stuff. So what I want to do now, having pasted this in, I'm not going to go through it. It's very well commented, and you can take a look. There's one thing that I have to do, right, if I want to be using this ML5 stuff, and that is I really need the ML5 library in my index.html. And we probably remember, hopefully, that I can get that in the Getting Started section of the web page. So I'm going to click on Getting Started, and I'm going to scroll down a little bit, and then there it is, right? There's my script tag. So I'm going to copy that, and I'm going to put that into my index.html. I should say that the framework that I just pasted in, of course, is provided in the notes for this lecture, right? That didn't just come, it didn't just come from nowhere. So I paste that in, and let me just run this for us, just so that we've got it sitting in front of us. I'm going to allow the camera. So the differences in this version is that it says loading Cocoa SSD, so that you know that currently the model is loading and nothing is ready yet, so you don't get impatient while you're waiting. And then there we go. So then the model loaded, and then it switched across into a different state where it is displaying the webcam, and it's a little confidence value, right? And that's it. So then we've got the same stuff, right? Scissors, that's good. I don't think I have anything else near me that it could actually recognize. You can get it to recognize weird things sometimes if you just, I mean, this is a whole other thing. I'm not gonna get obsessed with that. So this is the framework. It's just a light kind of a polishing of the stuff that you already get on the ML5 website. But the important thing, right, is if I wanted to now play with this, which is really the point, like now I can let my imagination run wild. Like what if I wanted to change this so that it's something that hates scissors specifically? So what if I wanted to censor scissors? Well, currently, the way that this code works is it's got this array of predictions. I called it predictions. It's going through all of the predictions, getting the object that was predicted and highlighting that object. The highlight as in drawing a bounding box around it. So what if instead of that, if I said if object.label is, so we know that's the thing that contains the label. If the label is scissors, I want to do one thing, and otherwise I'm going to highlight it in the usual way. So if the object label is scissors, instead of highlighting it, I'm just going to draw a black rectangle around that object. So let's do that. This is just a very quick, silly example of a censorship. So I'm going to draw a rectangle around object.x, object.y, object.width, object.height. Again, those are those properties, right, that we identified when we were looking in the console of what was available to us. So there was label, was one of them, that tells you what it is, and then there was x, y, width, height, that told you the bounding box. So now if the label is scissors, and only if it's scissors, I'm going to draw a black rectangle around the bounding box, and otherwise I'm just going to highlight the object. Okay, so what happens? How does that change the program? Like that, right? So it's censoring the scissors. It doesn't like scissors, or I don't know, it finds scissors pornographic, which, I don't know, let's not go there. But that's just a really, really simple example, right? The key thing here is we're using the data. That's really what it comes down to. Once we master and get comfortable with the idea of load the model, start predicting, really all that we need to do then is like, what are we going to do with this information as it comes into our program? And the data that we're most obviously using is the label, the x, y, width, and height that tells us the area where the object is, and there's also that confidence, that confidence value, which we can use to mess around with as well, right? So then the possibilities are endless, right? So you could censor the scissors, or you could use the scissors as a mouse by using the x, y of the scissors to click buttons or something, or you could have a program that wants to just only see scissors and you've got to keep showing it different pairs of scissors to keep it happy, or it can judge how good your scissors are based on the confidence value. But really it all boils down to what can you do with the label and the bounding box and the confidence value. Like those are going to come in with the framework. What are you going to do with them in your program to make something exciting and strange? And that's what it all comes down to, right? That's the excitement, is we get this interesting input into our program, and we can just do whatever we want with it at that point. So master the framework and then start playing with the data. That's really the secret to using any of these features, and in today's case, the object detector specifically. So I hope you have fun with it. I think it's a really, really interesting, full of potential kind of technology that we can use in our programs. And I'll see you in the next video.